India's most comprehensive preparation platform. So today's session is on communication systems. So I'm going to solve a lot of questions based on communication systems. So it's a series of 2 sessions. Today will be 1 session, and tomorrow I'll be taking the second session. Right. So before continuing with the session, so this is my profile. I've done my master's from IIT Madras. So I've cracked GATE twice, and I've worked for many coaching institutions in the country, like MEDIZ, Academy, Engineering Circle, and many other coaching institutions. So these are my subjects of expertise: communication systems and signal systems, because that is the area I have done my master's from. And this is my Telegram group. So if you wish to ask me any doubts based on these 2 subjects, you can contact me on this group. Right. So mastering concepts for GATE 2023. So we are trying to cover a lot of concepts in YouTube channel for free through this series. So every subject will be taking 10 sessions. Very important concepts we'll be covering. So you can watch out our YouTube channel for attending these sessions. These sessions will be very conceptual, very important. Right. So you can subscribe to our channel if you wish to follow all these classes. And there is one more upcoming session tomorrow, 9:30 p.m. So I'm going to discuss this topic. If you have not performed well in GATE 2022, you don't need to worry. You're going to have many opportunities in future. Okay. So what I'll be discussing is, I'm going to take the case studies of 3 different students, my students personally. I have followed them from their preparation to now whatever stage they are in. Right now they are in a very successful stage, I would say. So 3 different students with 3 different capabilities, but finally ended up successful. One student is a above average student from an average college. First attempt is not very successful. Second attempt decently successful, and third attempt he got All India rank 1. Okay, he's definitely different from others. His thought process is different. Okay, what is his thought process? How did he overcome his obstacles to crack that All India rank 1? Okay, so I'll be telling you how to develop that mindset, or what kind of mindset you should have to overcome the obstacles that you are facing right now. So whatever obstacles you are facing right now, lakhs of students are facing the same obstacles, same difficulties, same negative emotions. Right? People, whoever can overcome that, only those people will come out successful. Okay, and the one more student is an excellent student out of his college, from a very good college actually, but first attempt not successful, second attempt no, third attempt, fourth attempt, fifth attempt. In the 6th attempt he got a good rank, and finally he's very successful, I would say. I would share more details about him in the later session. Imagine, for 6 attempts he's continuously attempting GATE. Means what kind of mindset he should be having, how strong his mindset should be, right? How many difficulties he would have faced, how many negative emotions he should have faced, right? So all those things, I'll tell you what is his mindset, and I've talked to him personally also. He have given me some suggestions to you guys. So I'm gonna tell you those suggestions as well, and I'm gonna tell you about one more student who is like a below average student from a, you can say, very below average college. The college where students don't even think of writing GATE exam, not even writing GATE exam, forget about cracking, from that kind of college. But his aspirations are high. He worked very hard. He got a decent result in GATE, but finally he's now highly successful. The reason is his hard work and his preparation for GATE. Though his rank is not amazing, but still finally he ended up successful. What are the reasons? What is his mindset? All those things I'll be sharing in that session. So all those 3 stories. So in those 3 stories, the point is their thoughts. How did they overcome the negative emotions? All that stuff you have to understand. Okay, so we have to take the learnings from those 3 cases. So I'll talk about that. So you can don't miss out that session, which happens tomorrow at 9:30. Right. So before delaying any further, let's get into the session. So a session on communication systems. So today I'll be more focusing on amplitude modulation techniques, I mean analog communication and receivers topic. So in tomorrow's session I'll be focusing on questions on digital communication. Okay, so let's start with the topic. So first question, you can try solving it. I'll wait for a minute and after that I'll help you solve it. It's an easy question. Since we're talking about BARC HAL series, whatever is the level of difficulty in BARC HAL, similar level of difficulty I brought with the questions. Anyone? Sometimes in questions we might give an extra information also. So using that, seeing that extra information, you should not get confused. Whatever question they've asked, whatever information is sufficient, use only that. Sometimes that also happens in the question. They give some extra information also. In this question, I've done that. Anyone? So an AM modulated signal whose carrier frequency is 400 kilohertz has frequencies 420 kilohertz and 380 kilohertz. Okay, let me draw the spectrum. For an AM signal, if you draw the spectrum, they are saying that carrier frequency is 400 kilohertz, which means there is an impulse in the spectrum at 400 kilohertz, correct? And in AM signal spectrum, this impulse corresponds to carrier and there will be impulses corresponding to sidebands or message also, right? And they're saying that this AM modulated signal has frequencies 420 and 380 it seems. At 420 we are having one impulse, at 380 we are having another impulse. I'm just writing what information they have given. 380 kilohertz. Same impulses will be there on the negative side also, right? So the effective modulation index, they don't need to use the word effective because we use the word effective modulation index when there are multiple frequencies in the message. Actually, in this message, there is only one message signal with single frequency. And I hope you can guess what is the frequency in the message. Since the gap is 20 kilohertz here, it is a message is a sinusoidal signal with a frequency of 20 kilohertz. Okay, in message only one frequency. Okay, one frequency. That's why we are having only one upper sideband and one lower sideband. Message is a single frequency, message is having only one frequency. That's why we are having only one upper sideband and one lower sideband. Right. So when we are using a signal with multiple frequencies, message signal with multiple frequencies, then only we generally use the word effective. But fine, if they use the word effective, extra word effective, that will not change the meaning. Modulation index of the signal is 50%. Modulation index, we know the symbol is mu. When it is multiplied with 100, that is when they call it as percentage modulation. Mu multiplied with 100, we call it as percentage modulation. Okay, and it is given as 50%, which means mu should be 0.5. Now they're asking find the ratio of power at carrier frequency to total power. They're talking about powers. Whenever they are talking about powers, they are also talking about single tone modulation. So the formula for power is Pc into 1 plus mu square by 2. Whenever they talk about ratio of powers, ratio of any powers, sidebands to total power, carrier to total power, or any ratio, write this formula and just divide this into two parts. Pc plus mu square by 2 into Pc. This is the carrier power part and this is the sideband power part. This is the sideband power. This is sideband power. Now let's see what they're asking. They're asking us to find ratio of power at carrier frequency Pc. Power at carrier frequency is nothing but Pc divided by total power. Let me call it as Pt, the total power, which is equal to Pc divided by total power is Pc into 1 plus mu square by 2, which is 2 divided by 2 plus mu square. 2 divided by 2 plus mu square. So now we know what is mu value. Mu value is given as 1 by 2. You can substitute that. 2 divided by 2 plus 1 by 2 whole square is 1 by 4, which is equal to 8 divided by 9. In this, whatever information they have given about the spectrum, that is not relevant, that is not required. But why did I plot? Okay, whenever they give you this information in your mind, there should be some imagination happening. Imagination about the spectrum. If at all, if the spectrum is relevant, whatever imagination you had, that will help you a lot in solving the problem faster. Okay, so your imagination should work quickly. Whenever you read the question, you should imagine things. When they're giving frequencies, you should imagine the spectrum. That will help you a lot. My intention of plotting this is not because it is relevant for the question, but your thought process should be to plot the spectrum quickly in the mind, not on the paper, but in the mind at least. Right, so that's it. So answer is 8 by 9. So I hope it is clear. Hi, Mrunal. Mrunal, I'm seeing you after a long time. Ashutosh, hi, South. Good evening, guys. Okay. Next question. Similar question, but I'm asking you about a different thing to find. I'm asking a different question to find. Read the question, quickly answer it. It's very easy to answer. This is an easy question. I want you to answer very quickly. Hi, Teja. Priya Mohan, hi Priya, good evening. Ashutosh, wonderful, wonderful man. Very good, Ashutosh, very nice. Ronald, how can I forget you? You have been attending my classes since long time. 840? Come on. Surajit, come on. See, I'm asking you, what am I asking you? Bandwidth of AM signal. Okay, let me solve it. Same funda, if you can imagine the spectrum quickly, it will be a very easy question. I'm plotting only the positive spectrum. Similar negative spectrum you can plot. So the carrier frequency is 400 kilohertz, which means you can draw an impulse at 400 kilo. And they are saying that it has frequencies 420 kilohertz and 380 kilohertz. Same spectrum which we have plotted in the previous slide. Impulse at 420, impulse at 380. See this one? That's it. That is the spectrum. Same spectrum on the negative frequencies also you can plot. Now, the modulation index is not relevant here because they're talking about bandwidth. For finding bandwidth of amplitude modulated signals, modulation index is not relevant. But in a frequency modulation, it is relevant. Right, here this information is not required for us. Right, so they're talking about bandwidth. What is bandwidth of a modulated signal or any band pass signal or any signal for that matter? It is highest frequency minus lowest frequency. So highest frequency is 420 kilohertz. So this is the bandwidth, which is equal to highest frequency minus lowest frequency, which is 40 kilohertz. Right? That's it. Answer is 40 kilohertz. Or you don't need to plot this. I am trying to explain you in detailed manner. Okay, otherwise it's a very simple question. They're saying AM signal is having 420 kilohertz and 380 kilohertz. Okay, highest frequency present is 420, lowest present is 380. Difference between lowest and highest will give you bandwidth. You don't need to plot the spectrum also to answer this question particularly. But if they give you some complicated questions, then definitely plotting the spectrum will help you better. Okay. I hope you guys are following. Any doubts you can ask me. Good to hear, Mrunal. Very good. So Surajit, I hope you have understood that. How will it become? Okay, highest frequency is 420, 2 times 420 you have done. Huh? Okay, that's not correct, no. If the highest frequency, if that means there are frequencies from 0 to 420, then definitely you can say it is, and then also it is not 840, no. If I'm asking you about how to sample it, that is when you can give me an answer of 840. I want to sample that AM signal so that I will be able to reconstruct it. Or if I want to digitize this AM signal, whenever you want to digitize, you have to treat it like a baseband signal. If you treat it like baseband signal, whatever is the highest frequency, that you will take it as bandwidth. Then if somebody asks you to find the minimum sampling rate, then you will say that answer as 840 kilohertz. Okay. Rakesh, you're asking something. At what time I have started? Just few minutes back, 5-10 minutes back I've started the lecture. You did not miss much, only two questions finished. You can, recorded lecture also will be available. If you want, you can watch later. Shall we continue? Next question. Next question is based on amplitude modulation only, at a different model of question. It's an easy question if you know this concept. Amplitude modulated signal is plotted there. Looking at it, you can fetch some parameters. Using those parameters, you can find the required questions. Anyone? Very good, Saud Akhtar. Very nice. How about others? Come on, this is an easy question. I'm expecting a very quick answer from you guys. Very good, Ashutosh. Very good, Surajit. Okay, since many of you have answered, if anybody does not know the concept behind this, you can just watch whatever I'm speaking right now. Okay, so a DSBFC signal with full carrier. So they're talking about DSBFC, which means AM signal. DSBFC signal, in short, we also call it as AM signal. So they're talking about AM signal. They're asking us to find the peak amplitude of unmodulated carrier signal, which is C of t, AC cos omega ct. That signal, they're talking about AC. They're asking us to find AC here. So this is amplitude modulated signal, and whatever you are seeing here or here, that is peak amplitude of the AM message signal. Peak amplitude of amplitude modulated signal, which can be written as AC into 1 plus mu, which we also represent as A max, maximum peak amplitude possible in the message. Next, see this one. This is A min, minimum peak amplitude in the message signal. This is not A min, okay? This is A min. I'm talking about only peak amplitudes. Minimum positive peak amplitude. Minimum positive peak amplitude is A min. The formula for this is AC into 1 minus mu. And the midpoint of both of them, what is the midpoint of both of them? Whenever you want to find midpoint, how do you do it? Just average them. What is the average of these two? When you average these two, mu and mu get cancelled, it becomes AC. The average of these two is AC. So AC is equal to A max, maximum peak amplitude, and minimum peak amplitude. Just the midpoint of them or the average of them will give you peak amplitude of the unmodulated carrier, AC. So what is AC here? AC is equal to 150 and 30 average or 150 and 30 midpoint, which is 90. Okay, very good, very nice. So let me move on to the next question. So this is the idea, and one more thing also we can discuss from this question. One more question can be asked from this, and what is that? It is mu. How do you find mu value? From this relationship itself, from these two equations, since you know A max and A min, you can divide them, AC gets cancelled, and from that you can find the mu without using any formula. But if you want it as a formula, I believe you guys remember that formula. A max minus A min divided by A max plus A min. That is the formula. If you want to remember, you can remember. Otherwise, from these two equations itself, you can get the mu value. But for this formula also, you can get it from these two relations. If at all, if mu is asked in this question, you could have used this formula. Very good, Mrunal. Next one. Yes, this is what I'm asking in this question. I'm asking you to find modulation index in this. Very good, Priya. Same question, everything same. Instead of peak amplitude of the carrier, unmodulated carrier, I'm asking you the modulation index. Ashutosh, how is it 0, man? It is not even in the options. Very good. Okay, as I told you, the formula for mu is A max minus A min divided by A max plus A min. Since you know the formula, I've written it in the previous slide. Just let me substitute 150 minus 30 divided by 150 plus 30, which is equal to 120 divided by 180. It becomes 2 by 3, which is 0.66. Very nice. Many of you answered perfectly. Shall we move ahead? Moving on to the next question. This is a very good question. BARC level question only. But you have to observe things carefully. Come on, it should not take more than 2 minutes. Let's see who will answer first. No issues, Mrunal. Carry on if you are having some important work. Recorded lecture will be available. Very nice. Very nice, Surajit. Very nice, Saud. Very good. So they're talking about the frequency modulation. A message signal m of t whose Fourier transform m of f is shown in the figure. M of f is shown. This shape has nothing to do with the problem. We should not bother about the shape, but there is some useful information that is given in this figure. We will access that information. That signal m of t is to be transmitted from one point to another. It is given that message signal takes voltages from -2 to +2, it seems. We don't know the shape of the message signal m of t, we don't know the shape, but only thing that we know is highest amplitude possible in the message is 2 and lowest amplitude possible is -2. That is the information given. If FM system is employed for transmission, which means frequency modulation system, if you want to transmit a signal from one point to another, if it is wireless communication, definitely modulation is required. If it is wired communication also, sometimes we do modulation for the sake of multiplexing. Okay, so whatever reason it is, whether it is wired communication, multiplexing reason, or wireless communication, the mandatory modulation, whatever is the reason, modulation is compulsory. What modulation you are using? It can vary. You can use any modulation technique based on the convenience, based on what is your requirements. You might use different modulation techniques. So in this question, they are saying that they are using frequency modulation technique. And they are saying that frequency sensitivity is 30 kilohertz per volt. They are asking us to find the bandwidth of the modulated signal. Modulated signal is FM modulated signal. And we know the formula for bandwidth of FM modulated signal. And what is that formula? It is 2 times del F plus FM. That is one way of writing it. Or del F plus B also you can write. Generally FM is the notation that we, F subscript M is the notation that we use for sinusoidal single tone frequency modulation, where message frequency is FM. But if you're talking about this message is definitely not a single tone message. This message is having all frequencies from -20 to +20. It is not having single message, single frequency. So this is a general message. So we're not talking about single tone modulation. So instead of FM, we'll be using the highest frequency in the message. Instead of, because this message is having all frequencies, not just one frequency. So in that case, nothing much will change actually, nothing much will change. Only thing is, instead of FM, you will use the bandwidth of the message. If you want, you can use the other formula also, 2 into beta plus 1 into FM also, that is also fine. So how to find delta F? How to find delta F? And bandwidth of the message is given, that is the only information that is important for us here. That is 20 kilohertz. And what is delta F? We have to find delta F. Let us calculate delta F from the given information. They have given kf. What is the formula involving kf for frequency deviation? So maximum frequency deviation is given as kf into mod m of t maximum. That is the general formula which is valid for any message. So kf is given as 30 kilo into what is the maximum amplitude of the message possible? Message takes voltages from -2 to +2. So maximum amplitude possible is 2, which is 60 kilohertz is the maximum frequency deviation. You can substitute that here. 60 kilo. 60 plus 20 is 80. 82 are 160 kilohertz. That is the bandwidth. Okay. Very nice. So I'm moving on to the next question. I hope this is an easy question only. How about this one? Another question based on frequency modulation. Let's see who will answer the question first. Come on, make it fast. You can do it. Read the question carefully. Be focused. Understand what they have given and what they are asking to find. Mind that MFT is not sine signal, it's a sinc function. It's sinc. So recollect fundamentals about sinc function. If you know how to deal with sinc function, then only you can answer this problem. Or at least a few things about sinc function, then only you can answer it. A, okay. Let's see. Anyone else? Any other answers? Okay. I think C should be correct. Well, let's see. I'll solve it, then we'll decide. Anyone else? What happened to others? Okay. So let me solve it then. A message signal is given. So sinc function. So since you are able to see sinc function, let me quickly recollect a few things about sinc function. Sinc of 800t. Okay. So can we write it as sine 800 pi t divided by 800 pi t, right? We can express sinc of x as sine pi x divided by pi x, right? So I have just expanded that way. So sine at by pi t. This is a standard form of sinc function for which Fourier transform is easy to remember. What is the Fourier transform of this one? It is rectangle function from minus a to plus a. Whatever is the value you are seeing here, same value here and here, as a function of omega. You have to mind this as a function of omega with a height of 1 unit. So Fourier transform of sine at by pi t is easy to remember. Why did I write this? Because it's easy to, this Fourier transform is easy to remember. So if you can convert this sinc format, any sinc format into this format, then it will be easy to figure out the Fourier transform of it or bandwidth of it. Whenever somebody is talking about bandwidth, or when you need bandwidth of a sinc function, so first thing you should do, or bandwidth of any function, first thing you should do is find the Fourier transform of it, recollect the Fourier transform of it. Then it will be easy to find the bandwidth. Once you are able to figure out the bandwidth, you'll be able to figure out the sampling rate, Nyquist rate, and all those things. Right. So see this one, it is sine at by, it is in the same format, sine at by pi t, but the 800 is extra. Because of 800, bandwidth will not change. Because of constants, bandwidth will not change. Right. So Fourier transform of this also will be looking like this. Extra thing is height will be 800 for 1 by 800 for this. Okay. So what is the bandwidth of this signal? What is the bandwidth of that signal? Bandwidth of the signal is, it is A radians per second, or since generally we say bandwidth in terms of hertz, so divide it with 2 pi and you can say it as hertz, A by 2 pi hertz, right? So what is the Fourier transform of sinc of 800t? Keeping this in mind, we can find the Fourier transform of sinc of 800t, which can be written like this. So Fourier transform will be rectangle. The A value here is minus 800 pi to plus 800 pi as a function of omega. The height will not be 1 because it's not sine 800 pi t by pi t. There is an extra 800 here in the denominator. So the height will be 1 by 800. The height is not relevant in this problem, but whatever you are doing, if you do it perfectly, it might be helpful for you in some other problems, right? Right. So this signal, this message signal, I am having full clarity about the signal that they have given us. Modulates the carrier 50 cos of 2 pi fc into t. 50 is the amplitude. Carrier frequency is not given, it is just given as fc. So the modulation index is 3. Since they are talking about frequency modulation, they have given us beta value. This is beta. Beta value is 3. The maximum frequency deviation of modulated signal, they are asking us about maximum frequency deviation. And they are also asking us about the power in the modulated signal. Power in the modulated signal. What is the power in the FM modulated signal? In FM modulated signal, power is exactly same as unmodulated carrier power. Correct? In FM modulation, carrier power before modulation and after modulation are same. So what is the carrier power before modulation? Before modulation, this is the carrier. So the power in it is any sinusoidal signal power, peak amplitude whole square divided by 2, which is 50 square divided by 2, which is 2500 divided by 2, 1250 watts. If you see the options, it is given in kilowatts. So you can rewrite it as 1.25 kilowatts. There are 3 options with 1.25 kilowatts, so we have to solve delta F. So what is the formula for delta F? So since it is it's not a single tone modulation because message is having multiple frequencies. But you can use the formula beta times Fm. Instead of Fm, you can imagine it as bandwidth of the message. And how about that? Beta value is 3 and highest frequency in the message. What is the highest frequency in the message? It's 400 hertz, 800 pi radians per second. We generally access the bandwidth in terms of hertz. So what is the bandwidth? 800 pi radians per second or 400 hertz, which is 1200 hertz. So you can look at the options, only one option matches. Okay. So that sinc function is very, very important. I generally, whenever I look at the sinc function, I generally spend time on it because that's very, very important. Most of the times, whenever they want to complicate things, they use sinc function. Okay, fine. So let's move on to the next question. Another question on frequency modulation based on highest instantaneous frequency and lowest instantaneous frequency. Come on, make it fast. You know the message signal is clearly given and frequency sensitivity is given. I'm asking you to find maximum and minimum instantaneous frequencies. Very good, Ashutosh. Very nice. That was really quick. First, write down the formula that you know about instantaneous frequency of FM modulated signal. Very good, very good. So instantaneous frequency of FM modulated signal is equal to Fc plus Kf into m of t. This is the FM signal's instantaneous frequency formula. And if you want instantaneous frequency to be maximum, then Fc is a constant, only m of t varies here, and whenever m of t happens to be maximum, that is when you get maximum instantaneous frequency. And how about minimum instantaneous frequency? Fc is a constant, you can just copy it. We get minimum value of this one when m of t is minimum, kf into m of t minimum, and message signal is clearly given here. So Fc, carrier frequency, is given as 5 megahertz plus kf is given as 20 kilohertz. Is it 20 kilohertz? Okay. It should not be 20. It should be 200. Otherwise, you'll not get. No, it's correct only, no? Yeah. It's correct only. Fc plus kf is 20 kilo into maximum amplitude of the message is 10. M of t maximum is 10. Next, Fc is 5 mega plus kf is 20 kilo into, what is the minimum value of the message amplitude? It is minus 10 volts. 5 mega plus 200 kilohertz. 5 mega plus 200 kilohertz is 5.2 megahertz. And 5 megahertz plus 20 kilo into minus 10 is minus 200. 5 megahertz minus 200 kilohertz is 4.8 megahertz, which is option A. And you have answered beautifully well, that too very quickly. I appreciate that. Okay, I'm moving on to the next question then. This is an easy question. I'm assuming you'll be able to answer it within a minute. I'm asking about phase deviation and frequency deviation. I think there is a typing mistake here. An angle modulated signal. An angle modulated signal is given in this manner. Angle modulated means it can be FM or it can be PM. FM and PM, both of them, we can call them as angle modulated signals. So they're talking about peak phase deviation, del phi, which is also same as modulation index beta. This is what they're asking. And they're also asking us to find maximum frequency deviation del f. Notation sometimes can be, they might write it as del f max or simply del f also. Right, so from the given information, this is the phase part. Maximum phase deviation happens to be the maximum magnitude possible in the phase part. And what is the maximum amplitude possible in the phase part? When sign becomes 1, we get the maximum value possible, and that is 3 units. When message is not there, phase is 0. When message is there, phase will deviate. And what is the maximum deviation? Message was not there, base phase is 0. When message was there, maximum it can deviate up to 3 radians. The maximum phase deviation or modulation index is 3 radians. And how about the frequency deviation? Frequency deviation, since it is single tone modulation, you can observe that sinusoidal message is there. So the formula is beta times FM. Beta value we have already calculated. What is the message frequency? You can observe that it is 1 kilohertz 10 power 3. So this is 3 kilohertz. The option that matches is option A. Very nice. Okay, I hope that is clear. It's a simple question. Next one. This is a good question, very good question. The concept is based on frequency multiplier. If you know the concept of frequency multiplier, then it will not take much time to solve this one. If you are not aware of frequency multiplier concept, then it will be difficult to solve this. Looks like a complicated question, but it's not very complicated. You can solve it easily. Observe carefully, understand the given information, and do it carefully. Some amount of calculation is involved. Come on, do it carefully. This is narrowband FM modulator. The output of narrowband FM modulator is FM modulated signal or narrowband FM modulated signal. FM modulated signal with small beta value, we call it as narrowband FM signal. Narrowband FM signal or wideband FM signal, it is both of them we can call it as FM signal only. Right, for FM signal, important parameters are frequency deviation and carrier frequency also. So here they have given us carrier frequency as 200 kilohertz and frequency deviation as 25 kilohertz. Right, so let me quickly recollect the concept behind frequency multiplier. What happens when you pass an FM signal through a frequency multiplier? I will do a quick revision. Using that, you will be able to solve the question very easily. If you pass an FM signal through a frequency multiplier, at the output also you will have an FM signal, but a different FM signal. The parameters will change, but it will still be an FM signal. FM signal means the important parameters are FC, carrier frequency, frequency deviation, beta value, message frequency, right? So these are the important parameters. So what happens? What is the relation between them? So the carrier frequency after passing through frequency multiplier is, it will change, and it will change by frequency multiplier means it will have a parameter n, as the name says, multiplier. How many times the frequency gets multiplied? That factor is very important for that block. Let us denote it as n. It is n times it will change. Carrier frequency will change by n times. Frequency deviation also changes by n times. Beta also changes by n times, or specifically increases by n times. Message frequency does not change. Message bandwidth or message frequency does not change. Modulated signal bandwidth will change, but internal message is there, na? Internal message inside the FM modulated signal, whatever message is there, that message bandwidth or message frequencies, that will not get disturbed. Fine. So this is the funda. So now they are saying that FM signal, it is having a frequency deviation of 25 kilohertz, carrier frequency of 200 kilohertz. Now this is being passed through two frequency multipliers. Instead of one frequency multiplier, they are saying two frequency multipliers. So these two frequency multipliers together, can we write as a single frequency multiplier? Those two frequency multipliers together, I am writing it as a single multiplier, single frequency multiplier with a multiplication factor of 64 into 48. Is that okay? What will this do? This will increase these parameters by 64 times. This will again increase by 48 times. Effectively, how many times it is being increased? It is 64 times, and after that again 48 times. Totally 64 into 48 times. So effectively, these two frequency multipliers together, they will behave like a single frequency multiplier with a multiplication factor of 64 into 48. Right. So what is the frequency deviation at the input of both the frequency multipliers? FC here is 200 kilo, delta F is equal to 25 kilo. Now tell me this, what is the frequency at the output of the second frequency multiplier? It is equal to, it will change by n times, and what is it, n value? Both frequency multipliers together, n value is 64 into 48, and what is the original carrier frequency? It is 200 kilohertz. And frequency deviation, the new frequency deviation also increases by n times. And the n value here is 64 into 48 into 25 kilohertz. How much is that? Anyone have calculated? 64 into 48. Can you calculate it and tell me? I don't have calculator access to me. Okay, let me access the calculator. 64 into 48 into 614 megahertz. Okay, and divided by 8 is 768. Okay, this is the answer. Answer will be D. Is that okay? Is your calculations matching with mine? Looks like a complicated question, but it is an easy one, provided you've understood frequency multiplier concept. Yes, we can cascade, Surajit. We can cascade, na? Why can't we cascade? Two frequency multipliers together. Together to both of them. Just to make the calculation easier, I have cascaded them. I'm representing it as a single frequency multiplier. See, I'll just tell you a simple funda. So, cos of some angle will be there. For example, AC cos of theta of t. What does frequency multiplier do? It will increase the angle by n times. It will increase the angle by n times, which is 64 times. Correct? Now, after passing through this, whatever is the angle, this will increase by 48 times, which means it will become AC times cos of 64 into theta of t already is existing. Because of this frequency multiplier, another 48 times it will increase. The angle changes by 64 times because of this frequency multiplier, and because of this one another 48 times. Effectively, it is increasing by 64 into 48 times, which is as good as telling both frequency multipliers I've done. I'm representing it as a cascaded one. Yeah. I did not. Okay. Okay. Fine. Good. That's a good observation. But my intention is to remove this. I forgot to remove this. Because this is BARC series, right? So for this BARC series, I don't want to complicate the question much more. So I have reduced the complexity of the question which I have prepared earlier. So I did not give any block here. Though I have given an arrow mark, I did not give any block. Na? If I had given a multiplier block or a mixer block, then you have to take this into consideration. But I did not give anything like that, right? Okay, but if I have removed these things, then it would have been more clear. But as you said, if these arrow marks and mixers are there, then cascading is not good. You should not do cascading. Okay? Yeah, that's a good observation. So these things I should have rubbed them. Okay, and another question that I prepared, there was a mixer here, mixer block. If you want, you can try this question again with a mixer block. That will take more time, but that is one very good question. The difficulty level will be higher, but since this is BARC series, I want to reduce the difficulty level. Okay, I'm assuming that these things are not there. That is only in that case only I can cascade them. Otherwise, I can't cascade. If there was some block in between here, some mixer or some other block, I can't cascade them. I can't mix the blocks and treat it like a single block. I can't do that. Okay. Very good observation. That is how you have to listen to the class. You should ask me. You should question me if there is something confusing or some mistake in the question. It's a good way of understanding the class. Very nice. Next one. One more question. Come on. Make it quick. That should be an easy question. Without any filtering, a broadcast station at 2900 Hz is heard together with another station at 3900 kilohertz on a superheterodyne receiver. The IF employed would have been. They're talking about superheterodyne receiver. There is a problem with superheterodyne receiver, and that is image frequency problem. Okay. So the information given in that is, okay, they're talking about, yes, there is image frequency heard, and they're giving you the image frequency. Very nice. Very nice. Bhupati Balakrishnan, why is it D? General, for general FM system, the standard parameter is 455 kilohertz. Agreed. But in this question, it's different. In a practical FM radio system, yes, it is 455 kilohertz. But I'm not talking about practical FM radio system. I'm talking about, in the question, whatever is the information given, based on that, you solve the question. Okay. Okay. So the broadcast station at 2900 hertz is heard together with another station. Why will they hear another station? They want to hear to this 2900 kilohertz, which means that is the center frequency. That is the center frequency that we want to listen to, or that is the tuned frequency, you can say. Tuned frequency is 2900 kilohertz. Tuned frequency. Now, why are they listening to some other frequency? Because of image frequency problem. We want to listen to 2900, but some other frequency is also being heard. That is the problem with superheterodyne receiver. And what is the other frequency that we hear? 3900 kilohertz. What do we call this? We call that as image frequency, and that is 3900 kilohertz. What is the formula for? What is the relation between Fi and Fc? What is the relation between image frequency and tuned frequency? The relation is, it can be Fc plus If, sorry, Fc plus 2If. Is it only Fc plus 2If? It can be Fc plus 2If, or it also can be Fc minus 2If. Both are correct only. In some situations, we can choose this, or we can choose both of them. Okay, we can choose both of them based on what is the local oscillator frequency. So this is the image frequency if local oscillator frequency was Fc plus If. If local oscillator frequency was Fc minus If, in that case, image frequency is Fc minus 2F. What could they have chosen? So it is slightly confusing, but see the given information, then you'll understand what kind of image frequency they are using. Is it Fc plus 2F or Fc minus 2F? See the image frequency, it is greater than Fc, which means they should have used Fc plus 2F, which means they should have used local oscillator frequency as Fc plus If. Is that okay? By looking at the relation between these two, you can understand clearly whether they are using local oscillator frequency as Fc plus If or Fc minus If, based on which image frequency will be decided, right? So now, so it is given that Fc plus 2F is 3900 kilohertz, and we know what is Fc, it is 2900. You can substitute that. 2If is equal to 3900 kilo minus Fc, and Fc is given as 2900, difference will be 1000 kilohertz. So If will be, 2If is 1000, If will be 500 kilohertz. You don't need to put the pen also. It's easily doable in our mind itself, because the difference between these two is 2If. Difference between these two is 2If. If you have recognized that, If will be only half of it, which is 500 kilo. Okay. Balakrishnan, I hope you have understood. Is it clear till this point? So I have covered questions from analog communication. In tomorrow's session, I'll be covering questions on digital communication. Okay. So the tomorrow session will also be at 6 p.m. Same session, the continuation session. So we'll be doing some questions based on BARC and HAL series only on communications, especially digital communication. Same timing tomorrow, and tomorrow itself at 9:30 p.m. I'm going to discuss this topic. As I told you at the starting of the class, I'm going to take 3 case studies of my students, so who are from different backgrounds, different capabilities, but finally highly successful. what is the reason behind their success? They also have not performed well in GATE in their first attempt, second attempt. Some students in multiple attempts also. But finally, they have come out successfully. So what is the reason behind it? So what is their thought process? So what should we learn from their success stories? So all those things I'll be discussing in that session. So don't forget to watch it. Even if you are writing GATE exam in the next year or the next year, whichever year you are in, even if you are successful in GATE exam also, if you have got very good rank or if you have not got good rank, for all of you, tomorrow's session will definitely help you a lot. In the way you should think, in the way you should proceed, in every angle it will help. Because I'm talking about case studies, I'm talking about stories of different students who are successful, who have failed in multiple attempts, okay, and how they have become victorious. Okay, that will be a very useful session for you guys. So that's it from my side. So we'll meet again tomorrow at 6 p.m. and 9:30 p.m. So if you have not subscribed to the channel, you can subscribe to the channel. So that's it, guys. Thank you. See you tomorrow. Have a good day.